Okay, fine. Good evening, children. I hope I'm audible to all of you. Right. Once again, it's great to be associated. So today we'll be looking at important, topics. So right from 12th standard, which is important for your comparative point of view. So today, one such chapter has been chosen. In fact, it's a combination of two chapters. Electrostatic is in a branch, in physics, which deals with the study of electric charges which are at rest. So electro means electric charges, and statics means it's basically rest. So we are going to learn about electric charges at rest. We'll be studying them, different aspects of that we'll be looking at in today's lecture. Okay, so that is what today's lecture is aimed at. So this is 12th standard portion that we'll be looking at. Okay, so for some of you it might be different, but you can still understand. It's very similar to the concepts that you have learned in ninth and 10th standard. So you can try to correlate the concepts, and then once we dive deep into the formulas and other areas, then you'll have a clear cut idea of how to approach numericals from the electrostatic point of view. All right, so we'll start off without any further delay. Certain basic terms is what I'm going to first introduce before we get into the core concepts. Okay, one such concept that you guys should be knowing is quantization of charge. Okay, so what is meant by quantization? Let's look at that. Some of you might be knowing it. If you already have information about what is quantization or any topic that I'm telling, if you have an idea, if you would like to contribute, you can definitely unmute and you can answer. All right, so we'll look at what is quantization. Quantization of charge. Now, what do you mean by quantization of charge? Quantization is basically the minimum possible denomination of charge that can be transferred from one body to the other or vice versa. I repeat, quantization of charge means the minimum denomination of charges that can be transferred across bodies. You call that as quantization of charge. For example, when we talk about currency, we all know that minimum currency that can be circulated as far as the Indian economy is concerned, we have 1 rupee, 50 paise here and there possible. Nowadays it's very hard to see that also, so we can just say minimum denomination is 1 rupee, not less than that. Okay, as far as the currency transactions are concerned, not I'm not talking about the digital money. Fine. So that's the idea. So that is quantization. So quantization is, I repeat, the minimum denomination of charges that can be transferred across bodies. So we'll see what is quantization of charge in terms of a mathematical expression which tells you q is equal to n into e. Now here, q represents the charge in coulombs, n represents an integer value, it is an integral value, and non-zero integral value that you should know. Only positive integers are considered for n. E is nothing but the charge of an electron. I repeat, q is charge in coulombs. Okay, charge in coulomb. Now coulomb is basically the SI unit of charge. Unlike how we have the SI unit of length as meters, okay, and force as newtons, that way the unit of charge is measured in a quantity called as coulomb. So it's, the spelling is COULOMB. In short, we write it as capital C. So that is the unit of charge. And n is an integer value. You can say it's an integral multiple. Okay, it's an integral multiple. And E is the charge of an electron. I hope you guys might be knowing the charge of an electron. The amount of charge that an electron always carries is constant. Some of you might definitely have an idea about this, but still, I'll tell you, the charge is 1.6 times 10 raised to minus 19 coulombs. So this is the value of charge of an electron. Okay, so this is the concept of quantization of charge. So any particular charge can be expressed as the integral multiple of the charge of an electron, which is q is equal to ne. That's the first concept for the day. With that, we'll move on. Okay, we go to the next one. The second concept. Now let us look at properties of electric charges. Basic properties is what I'm going to brush up. Properties of electric charges. Some of the properties you guys might definitely be familiar with, so you can try to correlate. The first property is electric charges are quantized. So already I have introduced that concept. So electric charges are quantized, which means you can express electric charges in terms of multiples of electrons, integral multiples. That's the first one, first property. Second property is that electric charges are additive in nature. Okay, so electric charges are additive. Additive means you can add the charges. Okay, electric charges are additive. Third property, electric charges are conserved. Okay, so charges are always conserved. It holds good with the law of conservation. Okay, conservation of charge. So electric charges are always conserved. What does this mean? You cannot create a new charge out of nothing. So that's not possible. So charges are only those which are existing in nature. So you can't create something new. You can transform the charge from one form to the other. That is quite possible. So that is okay. But charges are totally the same. For example, if you talk about an object will have a particular amount of charges. So therefore, ultimately, you add all the charges, it will give you a certain number, which is going to be same. So that will not increase nor decrease. Okay, and you cannot create something new out of the existing charges which are there. So that's why electric charges are always conserved in nature. So how much ever they are, that is how much they will remain to be. So you can never have something extra, nor you can run in deficit of charges. So that's the third point. Fourth point, like charges repel and unlike charges attract. So this is a point which most of you might be knowing. So I'll just write it in short. Like charges attract and unlike charges repel. Okay, so this is again a property of electric charges. Whenever there are same charges, suppose two bodies are having positive charges, so they will repel each other. Okay, so two bodies are having different charges, positive and negative charges, they tend to attract. Now I'll give you a simple example. I hope all of you would have experienced electrostatic force. Okay, so when you comb your hair with a comb and take it close to tiny bits of paper, what is your observation? I think most of us would have tried this one point in our lifetime. So the observation is that the tiny bits of paper gets attracted to the comb. Why? Because the tiny bits of paper had a different charge and the comb had an opposite charge of it. So that's the reason opposite charges attract. That's a classic example. So when we brush our hair with a comb, or when you try to comb your hair with the comb, what happens? The comb gets charged. So it gets typically positively charged, and the tiny bits of paper that is kept, they're negatively charged. So then what happens when you take the comb next to the tiny bits of paper? It gets attracted because opposite charges will attract each other. So that's the idea. Okay, so like charges repel. I think I have written opposite. Let me just correct. Like charges will repel and unlike charges will attract. Okay, fine, I'm just corrected. Sorry about that. So this is the fourth property of charges. So these are certain basic properties that you should be knowing about electric charges, so which we have you know gone through. So going to the next point, third point, third concept, which is, so here we'll be learning about an important law called as Coulomb's law. So now we are getting into the core areas. Okay, it's called as Coulomb's law. Now, what is meant by Coulomb's law? We'll try to understand this. Okay, so instead of giving you the statement, I'll introduce the entire law in a mathematical form, so it's easy for all of us to digest. Okay, so according to Coulomb's law, whenever you have two objects, let me say object A, this is object A, and it has a mass of m1, and I have another object B, which is having a mass m2. Okay, now And these both objects are separated by a distance r in space. The distance between them is r. Okay, I repeat, if I have two objects having masses, m1 and m2, and they are carrying some charge, let me say that the charge carried by the object A is q1 and the object 2 is q2. Suppose the masses of those objects are m1 and m2, means both m1 and m2 is negligible. Even if you add them, it's going to be a very small number. So if it's having negligible mass, then according to Coulomb's law, the electrostatic force of attraction is or repulsion is directly proportional to the product of the charges, which is q1 times q2, and it is inversely proportional to the square of the distance between them. Having different charges q1 and q2 separated by some distance r in space and their masses are negligible, then according to Coulomb's law, the first point is that the electrostatic force of attraction between them is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So Coulomb's law is also called an inverse square law because of the second point that you see. Okay. Now what happens if I combine equations 1 and 2? So combining 1 and 2, what do you get? You observe that the force is proportional to q1 times q2 upon r square. This is what you get, right? Now, when I remove the proportionality sign, I introduce a proportionality constant. Thereby, the formula gets transformed as F is equal to, so I'll write the constant as K, okay, K times Q1, Q2 upon R square. And this is the expression for Coulomb's law, okay. So F equals K times Q1, Q2 upon R squared. Now, what is this K? K is a Coulomb's constant, which can be expressed as 1 upon 4 pi epsilon naught. Okay, so there's a constant. K is anyways a constant, can be expressed in terms of another constant called epsilon naught, so whose value is 1 upon 4 pi epsilon naught. And this is precisely when you apply all the values for this and simplify, you'll get the value of K as 9 into 10 power 9. So that's the value of K. And whenever we solve numericals, we will apply this value for K and then solve them. Is that clear? So this is all about the Coulomb's law. I hope this part is clear. So according to Coulomb's law, the force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. And the expression for that is F equals K times Q1, Q2 upon R square. You want to expand them, you can also expand. Post expanding, the formula looks like this. So F is equal to 1 by 4 pi epsilon naught, okay, times Q1, Q2 upon R square. Now here you might be wondering what is epsilon naught. Okay, I'll tell you that also. This epsilon naught is also, a constant which is called as permittivity of free space. Okay, it's a constant which is called permittivity of free space. That is what is epsilon naught. And it's having a value, children. So the value for epsilon naught is, it's actually a constant. I'll give you the value. It's 8.85 into 10 to the power minus 12. Okay, that's the value, that's the magnitude of permittivity of free space. Okay, only giving you the values. Units you can calculate by rearranging the terms. I mean, that is easy for you guys to find out. Okay, so here for us, numericals point of view is what we are looking. So therefore the formulas and the concepts are very important. Okay, so this is all about Coulomb's law. So with this we'll proceed ahead. Okay, we'll go to the next concept, the fourth concept. Okay, we'll look at the next one. So next we have the concept of electric field. Okay, so we'll see what is electric field. Okay, now electric field is basically, it is the region, whenever I say field, I hope you guys know what is field. Field is nothing but the area, the region or the space surrounding any object. We call it as field. A magnetic field is nothing but the region surrounding a magnet where its influence is felt. In the same way, we can understand what is electric field. Okay, so electric field is given by the letter E. So capital E, it's E bar, which is actually a vector. It has both magnitude and direction. Here also Coulomb's law, forces also can be expressed as a vector because force is also a vector. So electric field is nothing but the region surrounding electric charges. Okay, is typically your electric field. It is a region that exists around an electric charge where the force of the charge is going to be experienced or it is going to be felt. So that is your electric field. So I'll just give you the formula for electric field. We can express electric field as E equals F force upon Q naught. So here Q naught is called a test charge, a unit positive test charge. I repeat, Q naught is unit positive test charge, and F is your Coulomb's force. F is a Coulomb's force, and E is your electric field. So, electric field is the force acting per unit positive test charge at a particular point. So, you can also define electric field that way. Okay, so this is the fundamental expression for electric field. What do you mean by unit positive test charge? It is a small charge, okay, having magnitude of 1 coulomb, which is placed at a point, and we try to investigate what is the force experienced by it, what is the electric field, etc., etc. So that is why we use a unit positive test charge, naming it by Q naught. Okay, so Q naught is a unit positive test charge. Okay, so I've given you the fundamental expression for electric field. Force can also be expressed in terms of electric field by rearranging the above expression. You can write F force is equal to Q naught into E. Okay, this is rearrangement of the previous formula. So there are two different aspects of looking at it. Electric field can be expressed in terms of force, and force can be expressed in terms of electric field. So vice versa. So same expression in terms of force I've written. Okay, that's it. Now moving on to the next part. Okay, fifth concept. Now we are looking at what is the electric field. Electric field due to a point charge. Okay, due to a point charge Q. So now we try to understand what is electric field due to a point charge Q. So if you want to understand the concept of electric field due to a point charge Q, what we do typically is we bring in a test charge at a point. So say at point A, I have a point charge Q. I'm having a charge Q. Now, at some distance, say at a distance of R, okay, from this charge Q, I am placing another test charge. I imagine that I am placing a test charge called Q naught at this point B. The distance between A and B is R. Now having this scenario, now I know that the force between these two charges Q and Q naught placed at points A and B, which are separated by distance R, we can find out the force as we have just now learned. F is equal to K. Q1 here is Q. Q2 is Q naught divided by R square. Accepted, because this is what we learned in Coulomb's law. Okay, I have applied Coulomb's law to this. Now I am trying to relate electric field. You know that electric field is equal to force acting per unit test charge placed at a point. So F upon Q naught. Now what do you think will happen if I substitute the value of force here? The Q naught terms will get cancelled, and ultimately you will be getting E is equal to K Q upon R square, and that's the formula for electric field due to a point charge Q. This is the expression. Okay, I have just derived it for a better understanding. So the electric field due to a point charge Q can be expressed as E is equal to KQ upon R squared. So this is the formula. Okay, now moving on, I hope this part is clear. So as and when I'm explaining, ensure that you guys are writing it down, the formulas, for each and every aspect that we are looking at, so that it's easy to solve the numericals. So next, moving on to the fifth is done. So sixth concept. Okay. So looking at the next concept, the ratio of electrostatic force versus gravitational force. So ratio is important. So I'll give you ratio of electrostatic force versus gravitational force. Okay. So here when we say ratio, it is the ratio of the forces that we are looking at. So force, electrostatic force can be expressed as Fe, and gravitational force we can express it as Fg. Okay. So expressing it. So electric force, applying the formula, Coulomb's formula, K, Q1, Q2 are electric charges. So E into E is E square. I am writing it. Q1, Q2 are both equal to E. So K E square divided by the distance of separation is R square. R between them. So by R square upon gravitational force. So we will write it as G. G is the gravitational constant, universal gravitational constant. G times m1 m2 by r square. Here m1 is mass of your proton and mass of the electron upon r square. Okay, so r square will get cancelled off, and you're left with k e square upon g times the mass of the proton and mass of the electron. So substituting all the values and simplifying, you will arrive at a number called 2.27 into 10 power 39. So this number, it's good to remember to solve certain numericals. Okay, so this is a ratio. Instead of each and every time substituting and wasting time and finding out the value, it's better that you remember this ready-made value, which is a ratio of electrostatic force of 2 gravitational force. Okay, some numericals they ask questions based on this. If you know the ratio, you can immediately find out the answer. Okay, so that's the sixth concept. So then moving on to the next aspect. So looking at the seventh concept, children, for the day. So now we'll be looking at certain aspects called as the superposition principle, or we can say it's superposition theorem, that is sum of all the forces, okay, due to different charges which are placed at different points. So when you try to find out the sum of all the forces, so we can express this as net force or total force, we can say, acting. F total is equal to, you can just write it as F1 plus F2. So like this you can write. So typically we will write this as F12, okay, F13. So you can express like that. Due to one particular charge, the force experienced by one charge due to all the other charges. Okay, so we can write this as F12 times F13 plus F14. So like this it can go. Okay, so on dot dot dot. So this is total force experienced by charge 1, experienced by charge 1 due to all other charges. Suppose you have first charge, second charge, third charge, so on until you have infinity charges. Then what is the force experienced by the first charge or the charge 1 due to rest all other charges? So you can express it like this. Okay, so and then you need to apply Coulomb's law for each one of them, and then you need to individually, if you're doing it, you will do it like that. Or generally also, the expression can be written as, I'll give you a general expression. So F1, force experienced by first charge, is given as Q1 divided by 4 pi epsilon naught, okay, times sigma I is equal to 2 to n. Okay, n is nothing but the nth charge where n placed. 2 to n Qi, okay, upon R1I, okay, whole square times R1I cap. R1I cap is nothing but the unit normal vector in a particular direction. So when we solve children questions, you will have an idea of what is unit normal vector. Already I have taught you what is a unit normal vector when we learned vectors, the concept of motion in a plane. Okay. So unit normal vector, say A cap, can be expressed as vector A upon modulus of vector A, if you guys can recall. Similarly, we will write R1I cap, okay, can be expressed as your R bar upon modulus of R bar, okay, R1I divided by modulus of R1I. So this is what is, the unit normal vector. Okay, so that's about it, children. So this is how you express. Okay, this is all about the total forces experienced by one charge due to rest all other charges. So we can generalize and we can find out like this. Okay, moving on. Similarly, you can express it for electric field also. Electric field due to system of charges can also be expressed. I'll just write it here. This is force due experienced by system of charges. This concept is called superposition theorem. I'll write it here. Okay, superposition theorem. The force experienced by a charge due to system of n charges. Due to system of n charges. Okay, so that is your superposition theorem. So you can find out the total force experienced by any particular charge. Okay, so moving on to the eighth concept for the day. So the eighth concept is nothing but your electric field. So we'll be looking at the electric field due to a system of n charges. Okay, I'm writing it here. Due to the electric field due to system of n charges, you can try to find out by using this relation. So here I am giving it to you. The total electric field E bar can be expressed as sum of the electric fields of each and every aspect, E1 plus E2, so on until En. Okay, so this is the electric field due to a system of n charges. It can be expressed like this. So go and substitute the corresponding formula. You know that E is equal to KQ upon R square. So we make use of that particular relation. You can try to apply a summation for that. Okay. So by applying summation, K can be expressed, can be taken out of the summation operator. So K times, you can say sigma I is equal to, okay, 1 to n Qi divided by Ri square. Okay. So again, we can express this in terms of vector. So Ri squared times Ri cap, which is that unit normal vector. So this is very important. So the method of how to express the electric field due to system of n charges can be expressed like this. Okay. So this is the concept of total electric field due to n charges or system of n charges. We can express it like this. So having understood this, now we are moving on. Okay. So we'll look at the next aspect. Now we have, children, something called as electric dipole. Okay, and then you have electric dipole due to axial line, due to equatorial line. So like that we have different aspects. Okay, so before we get into all those aspects, we will solve some questions based on the concepts that we have seen so far, because this chapter is quite wide and it's quite big. So let's not rush in. So until the concepts covered so far, we will solve the questions, certain questions, so that you have an idea of how to approach the questions. Okay, so we'll see basic level questions and then we'll go to the advanced competitive questions. Right, so here we go. Okay, yeah, here comes the question. So some practice questions based on the topic seen so far. Okay, based on the above concepts. So here comes the first question. Here's the first question. Okay, calculate calculate the magnitude and direction of force. Calculate the magnitude and direction of force due to the system of charges given below. I repeat, calculate the magnitude and direction of force due to the system of charges given below. That's the question. This question is a general question. Now you have many sub questions based on them. Okay, the first sub question is A. So I'll give you only a diagram and then you can start answering the questions. Okay, you have two charges. Okay, so here at point A, and then I'm drawing another point which is B. Okay, it's a straight line. At point A, I'm having plus 5 coulombs of charge. At point B, I have minus 3 coulombs. Okay, and the distance between them is 10 centimeters. So you have to calculate what is the magnitude and direction of force. This is the first case. So like this, I'm giving you different cases. Okay, you can start solving. Then we will discuss the answers for each and every case. Second case is this. You have A, B, then C. This is the second one. First case, I only give you a system of two charges. The second case, I have given you a system of three charges. Okay, just to see how we are proceeding. All right. So you can try them. And then next case I'll give. All of you can start solving them. Then we can discuss one by one. Okay. Next C, we have again three charges. Yeah, so anybody is able to do it? I think first part somebody's tried. Okay, so three scenarios I've given so far. All right. Yeah. Okay, 135 to 10 power 11. Okay, we'll check. Okay. Fine. So here now let's try to discuss. First one, you have just two charges, q1 and q2 is 5 and 3 coulombs, minus 3 coulombs. Okay, so if you find out the force, so just apply the formula. So here are the answers. Okay, so for the first one I'm giving you the answer. So F is equal to k q1 q2 by r square. So directly you will use So directly you will use this formula and then you will find out the answer. Okay, as simple as that. Okay, so because it's only two charges which are involved, this formula will definitely work. Directly you can work with this formula and then you will find out. So therefore, applying this formula, you have the value of k as 9 into 10 power 9 times q1 and q2, which is plus into minus is overall going to be minus. 5 threes are 15. Okay, so divided by r squared, which is 10 centimeters. So I have to convert that in terms of meters. So 10 centimeters in terms of meter is 10 power minus 1 meter, the whole square, which is 10 power minus 2. Ultimately you will get 10 power minus 2. Okay, in the denominator. So take it up, the 10 power minus 2 becomes 10 power plus 2. Okay, which becomes which gets added up with 10 power 9. Okay, so 9, 10, 11. So you can write it as 10 power 11. There is a negative sign. You just need to multiply 9 and 15. Okay, so 9 15s are 135. So minus 135 into 10 power 11 newtons is the answer. You have to express this in proper scientific notation, which means I will express this as 1.35. I'm shifting the decimal place by 2 units to the left from 5. So if I'm moving towards the left, you know that the power of the 10 increases. So you become 12, 13. So into 10 power 13. That's the answer. The answer is, exact answer is 1.35 times 10 power 13 newtons. Okay. So that is how you solve this particular question. So proper evaluation, substitution, and then simplification. Okay. So when you do that, it's correct. Okay. So sign also plays a very important role. Now, what does this negative sign indicate? The negative sign indicate that opposite charges will attract each other, and hence the force is going to act towards the left. Okay. That is what is the meaning of indication of the negative sign. So the net force is going to act in which particular direction? So when you say force acts in this particular direction, the net force, or you can say the resultant force. Clear? So that's how you approach point the question A. What about question B? In this question, you're having three charges and the distance between the charges are equal. But you have different types of charges which are placed at point A, point B, and point C. They are not like charges. All of them are unlike, because first one is plus 5, second one I have kept it as minus 2, and third one is kept as plus 4. So when you have a situation like this and you wish to find out what is the net force, now you will decode this one by one. That is 2 by 2 you will take. First A and B you will have to resolve. A and B's resultant first to be found out, and then you will try to find out what is with respect to C. So like that you will have to decode it 2 by 2. So first find out for A and B what is the force that is existing between A and B and in which direction it is acting. That is the first point, first and foremost thing that you will do. I repeat, first you will find out what is the force which is interacting between points A and B. So how do you do that? By general method, by using the general formula, F is equal to K Q1 Q2 by R square. Using that formula, you will find out what is the force that is going to act at point B with respect to point A. I repeat, I find out what is the force acting at point B with respect to point A. So I'm writing it as FBA. So I want to find out what is the direction of force of FBA. So I am trying to investigate at point B with respect to point A. That is what I am doing. Is that clear? So now when I try to find this, I substitute the formula, which is directly, children, now I'm doing it directly. Okay, so 9 into 10 power 9. Q1, Q2, evaluate. Plus into minus minus, 5 twos are 10. So minus 10. Okay, into minus 10. See, I'm using parenthesis so that you don't get confused. Okay, divided by r square. R square is 2 centimeter, the whole square. I'm writing it directly. 2 square is 4. Centimeter square is 2 meter square will be 10 power minus 4. Okay, because 1 centimeter is 1 by 100 meters, which is 10 power minus 2. You square it, you will get 10 power minus 4. Okay, I have written it like that. Okay, I hope there is no confusion here. Now you first find it out like this. Once you have found this out, see here, you don't express in decimal, keep it as fraction. Okay, 9 is odd number, 4 is even number. It's fine, just leave it at that. So I can express this as 9 by 4. Okay, final answer you can convert to decimal, but not before that. 9 by 4 into, then now you evaluate the power of 10. Okay, you have a negative sign, not to forget that. So minus 9 by 4. Okay, minus 9 by 4 times, what is the power of 10? Minus 4 coming up becomes plus 4. 9 plus 4, 13. 13 plus 1, there is 110 also. Okay, so 13 plus 110 is 14. So negative 9 by 4 into 10 to the power 14. Okay, newtons. And this is what I will get. Okay, so this is the value that I am getting for the force acting experienced by the charge at point B due to point A is what I have found out. And how is it, in which direction is it acting? It is showing negative sign. So the direction in which it is going to act is typically going to be, now B is negative charge and A is positive charge. So obviously they are going to attract each other. It is not going to be a repulsive force, rather it is going to be an attractive force. And B is attracted towards A, and that is why negative sign, it is going to act towards left. Now you see how I'm resolving the question. So at point B, the force FBA is acting towards left, as shown like this, whose value is minus 9 by 4 into 10 power 14 newtons. Done. So now I have found out what is the force at point B due to point A. There is one more charge now left at point C. So now coming to point C, now the charge is plus 4 coulombs. So here you have plus 4 coulombs. The distance of separation between B and C is 2 centimeters again. Now you find out with respect to this charge, that is with respect to the charge at point B, you know that at point B you have a charge of minus 2, not to forget that. So you have minus 2 coulombs. Now you try to find out what is the force at point B due to point C. Find that out. So with respect to point C, positive. At point B you have negative. So you know again it is going to be an attractive force. It is not going to be repulsive, because unlike charges attract each other, right, based on the concept that we learned. So now find out the force experienced by point B, charge at point B due to charge at point C, FBC. Find out. Substitute in the formula. I am doing it directly again. 9 into 10 power 9 times plus 2 minus 2 into plus 4, which is going to give you minus 8, divided by r squared, which is again 4 into 10 power minus 4. Simplified, here 4 and 8 we can cancel. 4 ones are, 4 twos are. Okay, so 9 twos are 18. So 18 into 10 to the power, this time you will get 13 and not 14. I hope you guys know why. Okay, there it was a 10 and here it's not a 10. It's actually 8. So I cancelled out. So 18 into 10 power 13 newtons is what you will get. Clear? Negative sign, not to forget that you have a negative sign. Okay, so it's minus. Now see how the problem got solved or got resolved. At point B we have found out the forces due to the other two charges. So FBA we found out as minus 9 by 4 times 10 to the power 14 newtons, and we also found out the charge at point B due to C, which is FBC, equal to minus 18 into 10 power 13 newtons. Now BC, again if you see here, it is in which particular direction? Because negative sign, my arrow mark should be in the other way around. Okay, so arrow mark, you will show it like this arrow mark. Okay, so FBC arrow mark also will be in this particular direction, not like this, because negative sign. So both the forces are pointing in the same direction like this from the point B. FBA is towards the left, FBC is also towards the left, and they are collinear forces. Collinear forces, you can add them. So because the line of action is same, so the total force F net is equal to FBA plus FBC. Go and find out, substitute, add them. Okay, minus 9 by 4 minus 18 You can make it a common power of 10 so that you can take a common out. Okay, so I think you can express 18 in terms of 10 power 14 as, if I'm moving the decimal place to the left, so I can write that as 1.8 into 10 power 14. Okay, so minus 9 by 4 minus 1.8, the whole bracket into 10 power 14. So now this you will have to simplify. Okay, 9 by 4, now you can divide and make it into a decimal. I think you will be getting 2.25, so minus 2.25 and minus 1.8. Okay, times 10 power 14. And what's your answer? So 2.25 and 1.8, you have to add it. Negative 4.05, right? So negative 4.05 into 10 power 14 newtons is your answer. So that is how you find out, children. This is the method. Choose a charge, and then due to the other system of charges, try to find out. Okay. Now here I have chosen point B. It is not mandatory that you have to choose point B only. You can also choose point A. So A with respect to B, A with respect to C you should do. Otherwise, if you're choosing C, C with respect to A, C with respect to B. However you do, the combination is going to give you the resultant force, with respect to the point that you are choosing. So net force at point A, net force at point B, net force at point C. So appropriately you can use the formulas and then you can find out. Okay, so net force will always be same. Okay, this is the method, children. I hope this part is clear. Now moving on to the third part, the third situation. Answer for the C part we will see. Okay, so this was the answer for the B part. I'll write it here. Now solving question C. In question C, we had three charges. Okay, so three charges. You have A, B, C. Three charges are there. Okay, point A, point B, point C. In questions, they will appropriately tell you find the net force at point B or at point A or at point C. That will be definitely given in the question. Okay, here distances I will give you. Charges I will first write 2, 6, and 4. Okay, so you have charges as plus 2 coulombs, plus 6 coulombs, and plus 4 coulombs. Okay, this is actually the sides of a square, so the lengths are equal. Okay, so this is, you can take it as you know 2 centimeters. This also we'll take it as 2 centimeters for simplicity. Okay, now here if you have to find out the net force at point B. Okay, so F net at point B you're trying to find out. So when you try to find out the net force at point B, look at this, what we are doing. The force experienced by 6 coulomb charge at point B due to 4 coulomb charge, you know that both are like charges, so therefore F, the force will act in this particular direction because it is going to be a repulsive force. Okay, so your force at point B, force experienced by charge at point B due to C will act in this particular direction because it is repulsive. Similarly, force at point B due to point A will act in this particular direction, which is FBA. So both are acting along opposite directions from their line of action. First find out what is FBA and FBC, and then you should find out their result. Okay. So here, what is FBC? So again, let's evaluate by using Coulomb's law. FBC is equal to 9 times 10 power 9 into 6 times 4, which is 24, divided by 2 square is 4 times 10 power minus 4. Okay, 4 ones are 4 6 are, and 9 6 are 54 times 10 to the power 13, right? Newtons. So you got FBC as 54 into 10 power 13 newtons. Similarly, FBA, substituting 9 into 10 power 9, which is K, Q1, Q2, 2 6 are 12, divided by 4 into 10 power minus 4. So 4 ones are, 4 threes are, so 9 threes are 27 into 10 power 13. 13 newtons. Okay. So we have found out both values, FBA, FBC and FBA. Now, you should find out the resultant of these two forces, but they are not along the same line. Can you see they are acting along different directions? One is acting towards north and the other is acting towards east. So how will you find out the resultant of these two forces? What is the method to do it? So you will have to think a little. So here it is F, you just write it FBC on the top, and here towards right it was FBA. So the resultant of these two forces you are trying to find out. Now I hope you guys know whenever there are two vectors from a common point of origin, here they are acting from the common point of origin, which is B, you will apply parallelogram law and then you will find out. Okay, so whenever you have like this, so I think you guys know what is parallelogram law. Here the angle between both of them are 90 because it's at right angle to each other, it's a square. Okay, and you apply it in the formula of parallelogram law, which is F net equals to under root of, I'll take the first force as F1, so F1 squared plus F2 squared plus 2F1 F2 cos theta. So here theta is 90. I hope you guys know cos 90 is 0. So that term will go away. 2F1 F2 term will become 0. So this term can be neglected. So the ultimate answer will be under root of F1 squared plus F2 squared. Okay, that's it. So substitute that and then you will have to simplify. Okay, that is FBC square plus FBA squared. So take them, find out their roots, and then you will simplify it. Okay, so that is the method, children. Okay, so that's how you solve this particular question. Clear? So that's the approach to solve this particular question, based on this scenario. So given situation, purely you will have to think how to approach the question and then how to solve it. I hope you guys know how to substitute and simplify here. So just put the values. So it's 54 times 10 power 13 the whole square plus 27 times 10 power 13 the whole square. Okay, so here 10 power 13 itself will come out of the root. Okay, because it is common, so I can take 10 power 13 out of the root times under root 4 squared plus 27 squared. 54 and 27 you can express in terms of 9. Further you can extract that 9 also out. Okay, so 10 power 13 under root of 54 can be written as 9 times 6 whole square plus here also you can write it as 9 times 3. Okay, the whole square. So here also 9 threes are 18, right? 9 threes are 27. Okay, so 27 then. Here also 9 6 are can be written as 9 into 3 into 2. So even you can go with that prime factorization method. Okay, so like that also you can take out the terms. So that also I can take it out. Here I would like to take 9 threes are, which is 27. So here if I take 27, there 2 square will remain and here 1 square will be there. Okay, if you take 27 square, I'm taking it out as a common. Okay, so 27 twos are obviously it is 54, right? So therefore 27 square I'm taking it as common. So 10 power 13 times 27 under root 2 squared plus 1 squared. See how it got simplified. Okay, 2 square is 4, 1 square is 1, 4 plus 1 is 5. So the answer is 27 root 5 into 10 power 13 Newton. And that's your answer for this question. So be very clever whenever you do calculations. Apply, the mathematical concepts that you have learned for easier simplification. Okay, this is one such approach which can save time. Instead of finding 54 square, 27 square, and then taking it out of the room, that's a headache. It's better you can use such approaches. And remember, in the competitive exams, they will give you numbers which are perfect squares. So you should know the square numbers. That's very, very important. Okay, so learn the square numbers till 30 or 40, which is very, very useful. Okay, so till 40 square, you guys should know what are the values. 40, 50, if you know, it's very good. Okay, so better to learn. Fine. So this is all about it. So I hope this the concepts and the questions that we have solved today is clear. Okay, so we have looked at different scenarios. Try to practice them today itself, so that you get an idea of how you can approach the questions. Okay, so that's it, children. So any doubts you can definitely ask. Okay, good. One student has solved and given the answers. Nice. Okay, so you're posting the answers also. It'll be good even if you can unmute and tell the answers. Okay, so few answers you got it right, few of them are wrong. So this is the method of doing it. So yes, children, so with this we can wind up. You have any doubts, you guys can ask. Okay, otherwise we can wind up. So next class we'll look at more concepts and try to finish it, and then we can do competitive questions. It'll be a little slow. So the concepts, you'll have to be clear with the concepts. Once that is in place, you can easily solve the numericals. Notes I'll be sharing it with sir. Sir will be posting it in the groups appropriate. Fine. Yes, now the forum is, the class is open for doubts clarification. So anybody's having any doubts, you can ask somewhere you're stuck, somewhere you didn't understand, you didn't get what is the connect. Please ask. Please feel free. Don't hesitate. Okay, one student is asking, what is permittivity? Permittivity of free space, we call it. Okay, so permittivity is typically a constant which is taken in Coulomb's law. Okay, it is it shows you that to what extent the electric field lines can pass through empty space. Okay, it shows the ability of the electric field lines to pass through free space or vacuum. So that ability is called as permittivity. To permit the electric fields to pass through free space or vacuum, you call that as permittivity. Fine, I hope it is clear. So that value is a constant value. Okay, yes, welcome. Fine. So I hope it's clear, children.
Any other doubts you
Okay,
can raise or
so
send in the
please
group.
practice on a daily basis. Every day you practice, definitely it'll.
If you have
Yes,
any
children.
doubts, you can
Okay,
send in the
so you
group
can send it to
also.
the group also. So provided I'll definitely group too. Okay, fine. So we'll meet up again in the next lecture. So until then, bye bye. Take care. Good night.